Hello, everyone. My name is Talha Naqvi, and I am a staff developer at Shopify. For the last year, I have been working on improving Shopify app's performance. And when I say Shopify app, I mean the mobile admin companion app. And we have had some great results, and today I wanted to share the learnings with you. So before I even start, I would want to explain the purpose of this talk. Right? So the goal of this talk is not to cover everything that we did, but to highlight the most obvious things that are often overlooked and understand the impact of these problems with data. And hopefully, once you look at the impact, you will go back and look for the same issues in your own applications and benefit. So let's move on. So what was the main problem of the app that I wanted to address? It was slow load times for many screens. And we noticed that React Native migration was slowing down the app. People were adding more and more code. And over time, we noticed a trend that the homepage launch and subsequent app screen launches were getting slower. So our P75 app launch time was around 4 seconds. This is cold start. And after the launch, the navigation from screen to screen was around 1400 milliseconds. And for those who might not be familiar with P75, let me give you a quick explanation. What this means is that if your P75 is 4 seconds, that means 75% of the users will have an experience like 4 seconds or better. And merchants engage with Shopify app very frequently. What that means is they come back to the app multiple times throughout the day, which means speed is very important. So what was our goal? Our goal was to become a super fast app. We wanted our P75 app launch time to be around 2 seconds. And after the cold start, we wanted merchants to be able to move from one screen to the other screen in around 500 milliseconds. To simply put, we wanted app to feel as instantaneous as possible. And we, of course, wanted great dashboards to be able to track our progress throughout this journey, and also to be able to slice and dice data whenever we wanted to debug performance issues. Slicing and dicing here means that you should have relevant filters like app version, OS version, screen type, and many other things based on which you can filter the performance data and see where the problem is. And we wanted great alert systems because you don't want to keep checking these dashboards every day. And alerts are an important tool to maintain performance once you have achieved your goals. I've included a small screen, like a snapshot of how one of our condensed dashboard view looks like. And it shows the P75 trend and the P75 times. So this is something that I look at almost every day. Let's move on. When we were analyzing and profiling the Shopify app, we found 3 main types of performance bottlenecks, and I'm going to go through each of them here with you. So the first one was necessary work being done at the wrong time. Necessary work is the work that you cannot really avoid. It might be rendering of the screen, list, things like that. Something that you eventually need to do, but you might be doing too early and not at the right time. So let's look at an example of this that we found in the Shopify app. This is our products overview screen. It's one of the tabs that is prime focus of the app. And if you look at that red border that I have highlighted, that represents what the user will actually see when the screen loads, because that's the viewport, that's the screen size. And what we were doing is we were drawing everything outside of that red border along with the content that was visible. And if you roughly estimate, it looks like almost half of the content that's available here is unnecessary to draw on the first render. So this is excessive rendering during initial render. And of course, if you draw 50% extra, it's very likely that you spend 50% extra time doing it. And this is totally unnecessary. So how did we, there were many instances of something like this in multiple screens, and we wanted a generic solution which will address this problem. The most common way to render the screens that I see is just write these components, wrap them in a scroll view and render. But what we forget is scroll view will render everything in one shot, which is not ideal. We built something that we call lazy scroll view. It was built on top of flash lists. It's super simple. What it does is we give it an estimate that this is the average size of the items, which it will also help you compute. And then it renders the minimum amount that is required to fill up the screen on the first render. And then it pauses for the next draw frame and render the rest of the things later. So the goal is that at the end, you end up with the same amount of content, but it gets split across render frames so that your initial render is super fast. And this was super impactful and super easy to migrate to. Again, if you go to the blog that I wrote, I think back in February end or January, early March, you can go and see the code snippet that we use to implement lazy scroll view, and you can try it out. Let's look at a quick demo of which highlights how well this works. So this is our products overview tab. On the left side is how we used to render, and on the right is rendering with lazy scroll view. All right. Now that sometimes is too fast to see, so I'm gonna just slow down the playback so that you can actually see. Let me do 0.5. All right, let's play that from the start. Yeah. So there are some metrics also there. I'm going to play that just one more time so that you can see. You can see the screen on the right almost loads in half of the time. And the effort to migrate to lazy scroll view was like just change the name of scroll view to lazy scroll view. So I would highly encourage you to go and try it. Let's move on. So let's talk about another kind of excessive rendering. This could be something that happens before a relevant interaction. Take example of this horizontal list. Even after the screen is rendered, there is no need to render or recycle the items that are not within the visible viewport before the user actually scrolls. Now, technically, we could render these 15, 20 items after the first frame, and it might not do anything to the load times. However, it's just wasted rendering, because once the user scrolls, that's the right time to either render these items. If they are very expensive, then recycling them is a better solution, like what FlashList does. Instead of like drawing new items, FlashList just reuses the item that might have gone out of the viewport and updates it with new data, and that's prevents most of the frame drops that you might see because of mount. But the bottom line is there is no need to do anything with these items till the user actually starts scrolling. So how do we handle this? We just migrated all of our horizontal lists to FlashList once FlashList was ready, and it dropped our load time for the page significantly. Now, if you are using FlatList to render your horizontal list today, pay attention to initial num to render prop, because unless configured otherwise, FlatList will draw at least 10 items. And like if you look at this case, there is no need to draw 10 items, right? Again, if you're using FlashList, it takes care of this automatically. So I would highly encourage you to try a FlashList. A bonus idea, build every screen as a list. This is something that we have started doing in Shopify app. Every screen is built as a list from a granular set of components that are stitched together to make everything look like a screen. For example, for us, this header is a separate component, this search bar is a separate component, and each of these navigation items are separate components. and we go define the screen as a list of components, and then at the end of the day, it looks like a screen. But with this approach, we can only load what's visible and let Flashlist do what it does best, figure out and draw what's necessary. And this way, all of our screens just remain fast by default. All right, let's look at the second type of problem that we found. That's unnecessary work. This is the work that shouldn't be done at all. It could be repetition, or it could just be inefficient code. The biggest instance of this in Shopify app was background updates. When we were moving between screen to screen, we noticed sometimes the screens that were in background would just render again. But this does not mean they were mounting again, but just that the component function was getting called. And this was super expensive. The reason for this was mainly some of the hooks that were intended to run on navigation being subscribed to by these screens. However, in an application that's large and complex, sometimes it's difficult to control what's going to render when. So we came up with a strategy to just freeze the components that were not currently in focus. And we did it by using some very simple code. We would just keep a reference of what we returned in the past and just return the same from the component function so that no rendering happens. And we noticed that this made navigations up to 70% faster for some screens, which was very, very surprising. And it also made clicking and navigating throughout the app much more responsive because most of these updates were happening on click functions. So let's move to the next one. Restyle is one of our very popular styling libraries, which enables you to manage themes and introduce type safety to themes. We made it 5 to 10% faster based on the use case. And while we were doing this exercise, we noticed something very interesting. The main bottleneck was creating and copying objects. I have this small code snippet. There was a reduce call, and within the function block, we were copying certain style objects. And this was the root cause of that 10% slowdown compared to not using restyle. Now, creating, copying objects in a particular instance might not be expensive, but when you're talking about a library that you use in each of your components, the cost can quickly add up. So it's very important to look at extra objects, unnecessary objects being created in the critical path of your application and optimize. But if you do use restyle, upgrade because it's now faster. And at this point, the difference between using the performance penalty of using restyle is less than 2%. So it's practically nil. So you can go ahead and try and use restyle with full confidence. All right, let's move on to the next. And this is a very interesting one. So React Native doesn't always batch set state calls. So when you have a state and you say, set this, set that, the function block is executed again. And at least in React Native, if you do this from a promises resolve block, it's not going to be batched. Some of our screens needed multiple responses from native modules. And whenever this native module will resolve, some set state was triggered, and this set state was causing many component functions to just run again. And it was honestly, in some cases, just out of control in terms of the number of updates it was triggering. So we came up with a way to just batch all of these set states globally by default, and it made our screen load almost 30% faster. Again, the code snippet to do this is available on the blog. So you can go and look at it. I'll make sure that you see the blog link in some way later. And I'm going to talk about this a little more during the demo, but this was very, very interesting. All right, let's look at the demo. I'm gonna, I think, first play it. You can see the screen on the right loaded much faster, but it was too fast to see. So I will slow down and play it for do 0.25. All right, observe. you notice the load on the right was incredibly fast, and this change impacts the entire app. Here is a flame graph from Flipper. If you look at the number of render events that you see on the top right, almost 47 in number without batch. But once we batched everything, there were just 12, and the whole process just finished a lot quicker. So this is something that actually made our production app super fast, but it also made our debug app pretty fast because everything was more responsive. So even developer experience was significant. So I would highly encourage for you to go look at the code snippet and try it out. It can lead to some unwanted side effects. However, in our case, most of them are very easily addressable. All right, moving on. What was the third problem that we found? It was not making the best use of cache. We had a very robust caching system, but we felt that we weren't making the best use of it. So why is caching important? I have this experience when I talk to developers about caching. A lot of them tell me that their product teams weren't in favor of caching because it usually means showing the users or merchants in our case, stale data that isn't fresh. But what we need to understand that for apps that are engaged with frequently, can really benefit from caching because not every user is going to return to the app after 3 days or a week or a month. Some users return to the app multiple times during the same day. And in those cases, caching can be an incredible tool to improve the experience and load time. Think of a solution where you can have some kind of cache expiration date. So if the cache is more than a few days old, you can just expire it and not use it. But let's say if the user is coming back to the app after 1 hour or something like that, then you can definitely take advantage of it. So we noticed that the merchants who used to load from cache obviously were getting better load times. And we started to track our cache hits. What this meant was how many merchants actually load from cache first. And we found that the number was less than what we expected. It was around 50% for some screens and a little higher for the other. And we started to come up with strategies to improve that. We found a few bugs and we also implemented preloading. We figured out certain triggers where we could say with a high amount of certainty what the next screen was going to be. And we just used to preload that data on the disk. Once the data is there on the disk, if the user visits that screen, it means that they will face no network delay. And this is like a snapshot of one of the screens. If you see only I think 5% of the users, the green represents network load, orange represents cache load. Just 5% of the users load from network directly, while most of them load from cache first. So this was a significant improvement to performance. Based on your app, you might not have these obvious trigger points, but in those cases, you can have caching that expires quickly or come up with a solution that benefits those users who engage with the app frequently. So implementing all of this, just solving these obvious problems in a very generic way, we reduced our screen load times by 59%, and we made our app launch 44% faster. P75 is now around 2 seconds, and our screen load P75s are close to 500 milliseconds. This makes the app feel almost instantaneous. In the next demo, I'm going to show how our tab load feels like compared to how it used to be before this whole thing was started and how it is now. And you would see that it's almost instant. And let me play that again. So on the right, we are going to move to Orders Overview tab, and you will see how quickly it loads. On the right, you don't see the loader almost at all. I'm going to also slow down so that everyone can see better. Let's do 0.5. Play it. See, the right is almost instant, and the left takes quite a bit of time. This was our goal. We wanted the app to feel instantaneous and also to launch instantaneously. And I think we have come very close to where we want it to be. P75 times are at 500 milliseconds. So we are very happy with the progress, and performance work never really finishes. So we still continue to look for issues, look for regressions, and continue to optimize the app. But we are very happy with the results overall. And yeah, Flashlist played a very important role in this journey. So I would highly encourage you to go check it out, give it a star if it helps you. It's super stable. It's being used in Shopify app, Shop app, Inbox, POS. So you can use it today with very high confidence. Again, my name is Talha Naqvi. I'm available on Twitter/X at Naqvi Talha. So feel free to follow me and DM me with your questions. It was a pleasure to talk to you all today and share my learnings. And I really hope that you're going to go back and try some of these things. Thank you so much.